Alright, so it says points P, Q, and R and S lie on a circle. PQ is equal to QR. So them give us there. And then say PQR is equal to 116 degrees. But then basically put in everything for us. And now they say explain why QSR. So I'm going to find QSR first of all. QSR. So they want this angle. They want us to prove, oh, here comes Anthony's. They want us to prove that this right here is 32. How do we go about that? First of all, we have to just focus on this triangle right here. This is the key to getting it. Now, this is an isosceles triangle. So if we know the top part of it, then we can easily know the base angles, right? Why I'm finding this? Because you see this angle right here is equal to this angle right here. So we just need to prove that this is 32 and that's it. So let's see if we can prove if this is 32 because this one is equal to this. Angle in the same segment are equal. So we just need to prove that this is 32. And I think we can do it by looking at this, right? So this triangle that I mark out measures 1/8 because our triangle measures 1/8. And of course, we know that this angle is 116. So we just subtract 116 from it. That means whatever we get must share equally between these two angles because it's an isosceles. Once the base angles are equal, I think it makes it a little bit easier for us. So when we subtract 6 from 0, so you can't boom bar 1, 4, and this will be 64. So 64 must share between these two. So it will be 64 divided by 2, which gives it the base angle. So this will be 32. Yeah. So once you prove that this is 32, that one here is equal to that one here. And it's proven. Because all you have, they explain why. Angles in the same segment, we could give them that reason. Angles in the same segment are equal. And we'll get 2 marks for that. Alright?
So you would classify it as a quadrilateral?
No, because this don't join. They didn't join this part. For it to be a quadrilateral, it has to have 4 sides. I just basically put in these. So it's not really a quadrilateral. So see, we have 1, 2, 3. So it's basically 3 sides, and then you have the triangles then. But we see why it's 32, right? Once we can identify this isosceles, I think that was the key to it. This is an isosceles because I said this length is equal to this length. So if these two lengths are equal, it means that the base angles are equal. Let me try to draw it how it normally would look. So if we should turn it the other way, it will be this an isosceles, right? So these two angles would be equal. But guys, you have to learn to see it from upside down, sideways, whatever. Just look at they normally indicate with a stroke or 2 strokes, so the sides are equal. And that is enough to say it's an isosceles. Alright. So let's see if we can match up the next one and then we can discuss it. Alright. They're not easy, you know, guys. Over the years, people always. Alright, so it says the diagram shows a circle. Center OTA is a tangent to the circle at A. angle BAC, which is this angle, is 58, and BAT, which is this angle over here, so 74. And it's a calculate BOC. So I want to calculate this angle right here. So that's BOC. So they want this angle here. Immediately, guys, it should jump out here, right? Angle at the circumference, angle at the center. This is exactly what you look in the diagram. So all we have to do, just double this. It will be 58 times 2. So this work out to 2, 8, 16, 2, 5, 10, 116. Alright, now that we get this, they ask us for here, so now OCA. So they want this portion alone. So they make it a little bit difficult. But we still can find it, right? One way we can find it, we know that the entire angle, this is actually 74. Because it's equal to this angle right here. And also, if they didn't ask us for any other angle, but if they did, this angle, all of this, equal to this. So 74, bam, bam, bam. This work out to about 48. No, 8 and 4, 12. So sum 6. Anyway, they didn't ask us for that. Alright, they asked us for this. So if we know that the entire thing is 74, we can figure out a little piece there by finding the angle here. Only the little piece here and the little piece here. So you can look and see it's an isosceles because both of them are come from the radii, right? So it would be 180 when you subtract 116 because angles in a triangle add up to 180. And you subtract your little thing. Alright, so this is 7. This is 4. Oh, 64. Just like the other one. So these are actually 32. And remember, the 32 is for just this little part alone. From here to here, not all of it. All of it is whatever the difference of this. I'm going to work it out. I'm going to work out that part here first too. So if all of it are 74, and from here so to here so are 32, the remainder would be this, right? What they ask for. So this will give what? 2, 2 from 4, 2. So this is supposed to be 42. So this what they ask us for should be 42. I could try and prove it to see if it's correct, right? So we can do that. And we say this is supposed to be 160. So we could just continue. They didn't ask us for the rest, but let us try to see if that's something that you guys should do. Just kind of prove
Excuse me, sir.
Yeah, man, go ahead.
Can you go over that again, please?
Alright. Remember about everything. I like to show all this stuff. So you get this 160. If you look at this triangle right here, you can see this is an isosceles triangle. Agree? Because both of them are come from the radii. So that means that this one radius and this one radius. A line drawn from the center to the circumference. So that means this angle is equal to this angle. Agree? As an isosceles. So
I'm trying to write that right now.
No man, no write it. I would say focus on it and then you write. I always give you time to write.
Oh, alright.
Yeah. Because if you're looking from your book to this, that is not, healthy. So just look and then write. I think that is better. Alright. So we could go all over it again. So first we need to find this first. Because they ask us to find BOC. But we know that angle at the circumference is twice the angle at the center. We done that. So we multiply 2 times that to give us the 160. Alright, boom. Since we get the 160 now, we say that we can look at this triangle. I don't know what color this is. But the color that I put it in. We can see that this is an isosceles. So base angles must be equal. So if this is 116, these two angles are equal. So we just need to find the difference. So we subtract that from 180 and it comes to 64. So because 64 and we share it equally, we divide it by 2. So we get this to be 32. And this equal. Both of them equal. So both of them are 30. Alright, they want us to find this little portion here. But what I'm saying that this angle, which is a 74, is equal to this. Interior opposite. You have that in a book, guys. You can check it out. And also, this angle, all of it is equal to this angle here, so too. And we can figure out this angle, just in case they might have asked you that. We could find this angle here if you want it. But we could leave that out, because they never asked you. Right? So if this is 32, all of this is 74. All we have to do is just subtract.
1 minute, can I say something?
Yeah, man.
That part on the A line, you would have just add 74 and 58, and you minus it from 180 because I'm gonna straight line to get that part.
That is it. That is it. Yeah. So work it out and tell me. We just want to double check to make sure so we answer or we get correct. So work out this and then we can put it in a this and then we see if all of the angle them. Because the triangle must come up to 180. And we can double check to see if we're correct. Alright? It's very important to double check just in case you might make a little mistake. So we say that this should work out based on the fact that all of this should be 74. From here to here is 74. This portion is 32. That means we just need to subtract to get the remainder. Right? So 2 from 4, that leave 2. And 3 from 4. 3 from 7, leave 4. So this works out to 42. Because when you add these two, you're supposed to get that. Alright. Boom. Paris, you work out this portion here already?
Yes, sir. 14.
So that'll be 78 plus the 58. And then now, because angles on a straight line add up to 180. So this is 2, carry 1. 7, 1, 8, and 5. This is 132. Somebody just check with me. 132. Alright, so we're going to subtract that from 180 now. So this leave 8, 3 from 7, 4. So all of this can be 74. 3 from 7, that leave 4. 48, man. As I go borrow one.
48, sir.
Yeah, 48. Alright, so I could check it. This should be 48, right? That means.
So everything should add up to 360, you're saying?
Yeah, man, this angle here should add to 360. Because these are angles on a straight line. So the 48 correct.
And 80, I'm just saying if when you total all of them should go to 360.
You triangle them. So we can do triangle them separately. And there's 2 triangles, you know. Well, 3 basically. No, 2. You have this one here. And then you'll have the big one. So both of them supposed to add up to 180. So I can work it out. So if this is 48, that means that this little piece would be 16. Agree? Because we need to subtract that. So we can add this now. 16 plus 32 plus this plus the 42 and the 58. That must give you 180. Let me just try to use a calculator just to increase this. So we have 16. So let me just work it out with the calculator. Just to check. So 48 plus 42 plus 32 plus 58. Yeah. So that comes to 180. That's how I know it's correct, right? Because you're going to look at this big triangle right here. This must come to 182. Different from this. We checked this already. This comes to the 180. But this big one here should come to the 180 also. Doesn't matter what type of triangle, it's supposed to add up to 180. So if you add these 32 plus 42 plus the 16 plus the 32 plus 58, that form a triangle which give you the 180. We're soon forward there, bro. Soon forward. This plus all of this add up to 180 also. Angles on a straight line. So it doesn't matter how you check it, it's supposed to. And we could also check these 4 angles too, you know. That angle here plus this plus this must add to 360. So we could find this angle right here by just subtracting 116 from 360. And then add up these four and see if we get 360, because that's a four-sided. So there's so many ways, guys, we can double check just to see if we get the correct answer. So this will be 244. So you see that 244 here, plus the 58, plus the 42 and the 16, that's supposed to give you. Somebody check it for me. 244. Just punch this in your calculator. This is 16, I just a part here, the 42 and the 58. That must be a 360. Somebody, calculator, check it and confirm. 8 and 2, 10, and that 20.
Yes, sir, 360.
Alright. Thank you so much. So, you see, guys, there's so many ways you can check. You see, once you get the hang of it, guys, it's over for 6, you know. But it takes a lot of practice, a lot of work. You have to know them hand in hand, step by step. It's not easy. Alright? But once you know the rules, then, because that's how I do it. I literally have to check them one to see if it work out. Alright? So I'm going to see if we can do one more before we so you guys can go ahead and make the adjustment, and then we'll look for one more. Alright, this one said the diagram shows a circle with center O, so this is the center, right? Work out the size of the angle mark X. So if you look at it closely, you can see that this angle is angle at the center, while this is angle at the circumference. And CXC wanted to put the rule, right? We know that the angle at the center, or you can get it on capture. So the angle at the center is twice the angle at the circumference. Just practice them, guys. So that means that this is equal to 100, because there's like a double the 50. So this work out to 100. And of course, it's going to be 2 times the 50, which gives us that. So guys, see you tomorrow, alright? I will send the video shortly to the group. Notice the persons are not watching it, guys. We can't wait last minute, you know. Maths is so complex, and there are so many topics. You can't wait last minute to prepare. The madness. Oh Lord. So guys, I thought this is something like everybody got it.